Hello children, finally completed semester 2 physics paper successfully, and congratulations to all the students for your hard work and for your performance during the exam. Okay, yes, so when compared with the semester 1 paper, dear children, of course after that semester 1 paper, some students, not some, many students had some fear and tension, but I am damn sure that after seeing a question paper in your examination hall, definitely you might have got surprised by seeing the question paper, and you have performed very well. So for that, a big congratulations to all the students. And actually in today's class, of course you all performed very well, but still few students will have some what we can say doubts here and there. So in this video we are going to discuss the semester 2 physics paper completely, so that whatever the doubts which you will have will get it clarified. So first of all, children, before going to start first section A, question number 1, let us do the analysis of the question paper, children. So here if you can look at this, as usual, as we expected, yes, maximum marks are from electricity, that is current, electricity and household circuits together. And next it is from calorimetry, then radioactivity and electromagnetism, and next the last one is actually sound. But children, you cannot say that very less marks from sound. Why? The concepts from sound chapter is very less. Yes, for that concept, yes, these marks are very good only. Okay, children. And now we'll start question number 1. So children, look at the question number 1 here. Choose the correct answer, children. Here, the first one, free vibrations are, children, free vibrations or natural vibrations can occur only in the absence of external force. So here, according to the option D, children, look at the option D here. Vibrations with a constant frequency and a constant amplitude. That's right. Because in the absence of external medium, energy is not lost. So what will happen? Amplitude won't be decreased. So it remains constant. So question number 1 here. Question number 1, first bit, answer is D. Answer is D. Now look at the second question, and you also can see on the screen here. Children, the diagram below shows 4 sound waves. Which sound has a highest pitch? Children, pitch depends on frequency. Frequency means what here? Number of waves produced. More the number of waves, more the frequency. More the frequency means more the pitch. Now look at the question B, children. Option B. In option B, more number of waves are produced. So it has more frequency, means it has more pitch. So answer is B. Now third bit here. Third bit, the graph plotted for potential difference V against curve in ohmic resistors. Children, in the case of ohmic resistors, current is proportional to the voltage, that is the potential, which means what? Current increases linearly. As current increases linearly, whenever we draw a graph for a V and I, definitely we get a straight line which is passing through the origin. So here, which option is right, children, here? Curve passing through the origin? No. The straight line not passing? No. Yes, option C. A straight line passing through a origin is a right answer. Now, fourth bit. A main switch in the main distribution board is present in. Here, many students got confused and they have selected option live wire because a switch word is there. Of course, switch is always connected in live wire, no doubt. But here it is a main switch, children. What is the purpose of main switch? The purpose of main switch even to cut the live wire and a neutral wire at the same time. It happens only when main switch is connected to the live and as well as neutral wire. So the correct option is C. Now here, fifth bit. A conductor AB is kept along a north-south direction as shown in the figure. Now they are asking us to when the key is closed, children. So which option is right? They are saying, of course, as current is passing through the conductor, definitely magnetic needle gets deflected. But children, here don't forget that this is a case where magnetic needle is placed below the current carrying conductor. Don't get confused. This is very important. It is okay. So current wire is placed above the compass box. It is placed above the compass box. So here we have to use snow rule. Here we have to use snow rule. It is means what here? Whenever current passes from south to north, north pole of the magnetic needle gets deflected towards west. So here look at the option, the needle will deflect towards west, means here option D is right. Option D is right. Now look at the question sixth bit here. What is the question given? A coil wound around a piece of soft iron can become an electromagnet only when. So the circuit is open, no chance at all. A magnetic compass is present in the vicinity, not at all. A galvanometer is connected, no. A current flows in the circuit, obviously right. So current must flow, then only what will happen? The soft iron core behaves as if it is a magnet. In fact, that is called actually electromagnet. So the students who are good at the definition of electromagnet can do this question. So here the option D is right. Option D is right. Now question number 7, that is bit 7, first question, bit 7 children here. If water absorbs 4000 joules of heat to increase the temperature of 1 kg water through a 1 degree Celsius, then the specific capacity. Children, specific capacity formula is Q by M delta T. So here it is given that 4000 is a joule, okay, that is fine, joule. Mass is given 1 kg, okay, and temperature is 1 degree Celsius. So actually the answer should be 4000 joule per kg degree Celsius, but the option is not there here. This option is not there. But it is when you express in terms of kg. This also can be written as actually in terms of grams. It can be written as 4 joule per gram degree Celsius. So these both are equal. Yes. Now the option is there. Which option is right, dear children? 4 joule. Okay. This still can be 4 joule gram inverse degree Celsius inverse. So the correct option is C. Bit 7. The correct option is C. Okay. Fine. Now moving to the 8th bit. Moving to the 8th bit. Yeah. Water is used in a car radius. What is the reason? Children, this question is based on the applications of high specific capacity of water. So look at the option D, children. Its specific capacity is very high, so it can cool the engine without greater increase in its own temperature. Yes, it is a right. Why? The reason is C is inversely proportional to delta T. So children, more the specific capacity, less will be the rising temperature or falling temperature. Now 9th bit, the heaviest nuclear radiation is. Heaviest means what is, children? Mass should be more. Gamma is a massless, beta is nothing but the electron mass, so very least is negligible, it is only alpha radiation. So children, the mass of the alpha particle is 4 times than that of the mass of the proton, so it is the heaviest. So the answer is B. Now 10th one, day children. So it's a direct question. So it's an archaeological survey for a significant to study the decay of isotopes. We use actually it's a carbon. So the answer is given here, bit C. So option C is the right answer. So children, so this is the first question. So when compare with semester 1 day, children, yes, the MCQ questions whatever are given is almost all direct questions only. Okay. Now look at the question number 2. Children, in the question number 2, it is a question based on electromagnetism. Look at the question given. So the first question, the question 2, bit bit 1A. After studying the circuit and the magnetic compass carefully, state whether the switch S1 is open and closed. Many students, by seeing the diagram, they came to the conclusion that switch is off, switch is open, they thought actually. But dear children, the answer is, look at here, question 2, first bit A. So the answer is actually it is closed. Now you may get confused. Sir, in a diagram it is seen that it is not connected, just switch is given. Yes children. For that actually the reference is magnetic needle. So that is the question asked in a second bit, that is B. How did you arrive at the conclusion in A? Means they are saying that yes, we have written that here the switch is closed. But what base we are saying that the switch is closed? Children, we know that in general magnetic needle, that is the magnetic needle of the compass box, it is what it can show the north and south, that we know very well. But in a diagram, if you can see children, it is already deflected. It is already deflected. What you can see that. So it gets deflected when there is a current through the coil. Current can be in the coil when the switch is closed. So here the reference is magnetic needle. Magnetic needle. So here they are saying that how did you arrive at the conclusion in A? So by seeing the magnetic needle and it got deflected and it is showing south. Means what? Already it got affected by the magnetic field produced by the wire. It happens only when current passes through it. Okay, fine. That is the answer B. And C. What is the purpose of placing the magnetic compass in the above setup? Children, magnetic compass is placed to identify, to know the presence of magnetic field. That's it. To know the presence of magnetic field only, a magnetic compass is placed. That's it. Okay, fine. Now here, second bit A1. Give an important reason for copper to be used as a material for calorimeter. Children, because calorimeter, why you are using copper? Because copper has low specific heat capacity. Actually, writing that word is enough. You will get the mark. If you want to write more, yes, you can write. As it has a low specific capacity, children, yes, it behaves like it acts like a best conductor. So that what will happen for a small means without absorbing the what we get the heat. Okay, now what will happen? The heat is given to the ingredients which you have taken in the calorimeter. So actually, writing in a simple way, writing what is the correct answer? Simply due to the low specific heat capacity only, copper is preferred as a calorimeter. That's it, over. Now B. Look at here. A calculated thermal capacity of 40 grams of water. Children, here mass is given 40 grams. Okay, it is fine. And here specific capacity is given 4200 joule per kg degree Celsius. Children, here specific capacity is in kg, mass is in grams, so mass must be converted. So 40 grams is equal to 40 by 1000, it is 0.04 kg. So we know that, dear children, thermal capacity C dash is equal to mass into specific capacity, that is 0.04 into 4200. So here what will happen? 4 to the 8, so 60, 168. Then but what are the units? Units are here joule per degree Celsius. Joule per degree Celsius is the right answer. So for bit A 1 mark, bit B here 2 marks. Now third bit, children. Third bit is very important. So here according to the information, dear children, some students they face a little bit difficulty in this third bit of the second question only. So what is the question here? Look at that here. A circuit is given, fine. In the above circuit diagram, calculate the external resistance. Children, first of all, let R1 be 8 ohm. Just let us say R2 is a 12 ohm. Let us say R3 is a 2 ohm. Children, from the diagram here, R1 and R2 both are in parallel. So what is the resultant resistance? Rp is equal to R1 into R2 by it is R1 plus R2. So it will be 8 into 12 by 8 plus 12. This is going to be 96 by 20. Okay, children? Fine. So this is going to be 2 4s are 2 8s are by 10. So it will be 4.8 ohm. Children, it is only because these two resistors. But according to the diagram, children, according to circuit given, again these two, the combination means the resultant of these two resistors is in series with this 2 ohm. So finally, the external resistance R is equal to here R3 plus Rp. So it is 2 plus 4.8. This is going to be 6.8 ohm. Fine. First A bit is over. Now D1, they are asking us to calculate the current through I2. Children, it's very important. Current through I2 they are asking. If you want to calculate current through I2, children, yes, directly we have the formula. V is equal to IR. V is equal to IR. But here V value is not known. First we have to calculate the V value by using that diagram. Children, here it is given I1 is equal to 0.4 ampere, and let us say it's R2. R2 can, so you can take it as R2, it as R1, nothing is wrong, so that we will have we don't have any confusion. That is here R1 is equal to 12 ohm. Children, according to Ohm's law, V is equal to IR, that is I1 into R1. So this is 0.4 into the 12. Okay, children. So if you can look at here, this will be 4.8 volt. 4.8 volt. But children, here 12 ohm resistor, 8 ohm resistor, both are in parallel. So when two resistors are in parallel, the potential difference across the two resistors is same. So that is the logic here we have to use. So with that logic, children, with that logic only, so we are going to calculate I2 value. So we know that here V is equal to I2 into R2. From this, I2 is equal to V by R2. So V value is 4.8, R value is 8. So here I2 value is how much, children? It is a 0.6 ampere. 0.6 ampere. Now finally, in the bit C, they are asking us to calculate the total current. Children, total current I is equal to I1 plus I2. Anyhow, I1 value is given 0.4. Now I2 value 0.6. The total is 1 ampere. So children, this is a question number 2. Just copy it. We'll move to the question number 3. Fine, children. Look at the question number 3 here. The question number 3, it is given here A, B, C. Okay, socket is given, children, and 3 colors are given: brown, green, light blue. So children, this question is based on color coding. So question number 3, first bit. So children, we all know that earth is a green, and the light is a brown or red, neutral is a blue. But children, here the very important thing is that in a 3-pin plug, in the 3-pin plug means left side will be light, but whereas in a socket, right side will be the, what we can say, live wire. So it's very, very important. So first we have to identify here. A is a earth wire, okay. B is a neutral wire, fine. C is a live wire. So after writing this, after coming to this conclusion, now we have to identify. So brown color. So this is small a, brown color. Yes, very good. And here B is a neutral, that is a C, that is light blue, very good. Remaining one is that is B, that is green. That's it, children. So for writing this, you will get 3 marks. Okay, fine. Now second bit, question number 3, second bit. What is given? Why does it become colder after a hailstorm than during or before the hailstorm? Children, this question is based on the applications of high specific latent heat of fusion of ice. So here you must write the value of the what we get the specific latent heat or specific latent heat of fusion of ice. Then only you will get actually 2 marks here. Okay, na? Fine. So the specific latent heat of fusion of ice is, children, you can write either 80 calorie per gram, or you can write here as a 336 joule per gram. Children, first of all, you should know this meaning actually. So the specific latent heat of fusion of ice is 336 joule per gram. What does it mean, children? It means to melt 1 gram of ice at 0 degrees Celsius to 0 degrees Celsius water, it requires 336 joules of heat. Children, during hailstorm, can you say that only 1 or 2 grams will be what we can notice on the earth's surface? No, huge amount of ice is noticed. To melt, see, for 1 gram only 336 joule heat is required. Then to melt such a huge amount of ice, huge heat is required. And from where this huge heat is taken, children? It is absorbed from the atmosphere. See, in order to melt the ice, so much of means huge amount of heat is absorbed from the surroundings. Due to which what will happen, as the surroundings, that is atmosphere, is losing the heat, it will become colder. So you should write this value and you should write the explanation, then you will get 2 marks. Okay, fine. Now here is bit A, now bit B. Children, here if 2 bodies have the same specific capacities, then they will always absorb the same amount of heat if their temperature increases by the same amount. State whether the given statement is true or false. Children, here we need to understand one very, very important thing. So the amount of heat absorbed depends on mass and the change in temperature. Here mass is not at all given, change in temperature is not given. So with this information we cannot say that it is a same amount of heat is required. We can't say that actually. So the statement is false. We can say that the statement is false according to the information given in the question. Fine. Now third bit, children, this is a bit where few students, what we can say, they face a difficulty in doing the numerical. The thing is that here in general, of course we practice so many questions based on the calorimeter and all this thing, but here thing is that in the specialty is that here we need to consider the calorimeter also. Now let us see here how we can calculate the specific capacity of the metal piece and all these things. Let us see. Children, here the specialty of the question is that in this question the specific heat capacity of calorimeter also given, which means what here calorimeter also going to absorb some heat, so we need to consider that also. So according to the question given, children, here look at that, here is a metal piece of 420 grams which is 80 degrees Celsius is going to be dropped in a 80 grams of water present at 20 degrees Celsius. And the mass of the calorimeter also given, that is the 84 grams also given, which means what is, children, and here you may get one doubt. Then what about the temperature of the calorimeter here? Children, the temperature of the ingredients is the temperature of the calorimeter, which means what? Calorimeter also at 20 degrees Celsius only. Here this metal piece is at 80 degrees Celsius, which means what? Here metal piece is a hot body, water and calorimeter together they are cold bodies. Okay children, fine. And here after adding it is given that the resultant temperature is 30 degrees Celsius, resultant temperature. Then we need to find the change in temperature. Children, its initial temperature is T1, final temperature 30. So change in temperature is 50 degrees Celsius. And here as water and calorimeter both are cold bodies, their temperature is raised. So that is 30 minus 20 is a 10 degrees Celsius. Here also 30 minus 20 is a 10 degrees Celsius. But they are asking us to calculate the specific capacity of the metal piece, children. That is specific heat capacity of the metal piece, let us say C, they are asking us to calculate. Okay, now let us say here C1, so let us say the C1 value. So here is the C2 value, it is given 4.2 joule per gram degree. Let us say its value C3 is a specific capacity calorimeter, it is given 200 joule per kg. So it can be written as 0.2 joule per gram degree Celsius. Children, here this is completely based on the principle of calorimetry. So according to the principle of calorimetry, children, the heat lost by the hot body is equal to heat gained by the cold body, which means what here? Heat lost by the metal piece, it is a metal piece, is equal to the heat gained by the water plus heat gained by the even calorimeter C also. Okay now, so this one is M1 C1 delta T1 is equal to M2 C2 delta T2 plus M3 C3 delta T3. Now let us substitute the values. After substituting the values, yes, we can. So let us substitute the values here. So this is going to be 0.168 joule per gram degree Celsius. That's it. Okay children, so this is how actually we need to calculate the specific heat capacity of the metal piece. So it's purely based on the principle of calorimetry. Here actually you should write actual, children. According to the principle of calorimetry, heat lost by the hot body is equal to the heat gained by the cold body. That must be written. Okay children, let's copy it. Now look at the question number 4. Children, it is given that Rohit playing a flute and Anita playing a piano emit sounds of same pitch and loudness. And here question number 4, bit 1a, it is asked, name one characteristic that is different for a waves from the two different instruments. Children, it is given that already same pitch and a loudness. So there are three characteristics of the sound: pitch, loudness. Third one is a quality. So you must write as a quality. Children, here you can write as a quality or you also can write as a timber. You also can write as a timber. Okay, it is also accepted. Bit B, children. If now the loudness of the sound from the flute becomes 4 times that of the sound from the piano, then write the value of the ratio of the what we can say amplitudes of the flute and the piano. Children, we know that the relation loudness is proportional to the square of the amplitudes. So it is loudness of the flute by loudness of the piano is equal to what we can say amplitude of the flute square by amplitude of the piano square. Now they are saying that this loudness of the flute is becoming 4 times than this one. Okay now, so this can be written as AF by AB whole square is equal to 4 by 1. So it is AF by AB whole square. Sorry, this square will go that side. It will be square root of 4 by 1. That is 2 by 1. So the answer is, so the amplitude, the ratio of the amplitudes will become it is 2:1. So here we need to do the what we can say mathematical calculation should be done. Okay, fine. Now children, question number C. Define pitch of a sound. So children, how can we define the pitch of the sound? Here it is the characteristics of the sound by which what we can say acute note can be distinguished from a grave one of the same loudness. So that is the direct definition from the textbook. Okay, fine. Now the question 2, that is the definition is over here. Now question bit 2 of the question number 4. Name 2 factors on which the force experienced by a conductor carrying current placed in a magnetic field depends. Also state how these factors affect. Children, for this you need to recall F is equal to B, so that is A. We know that the force experienced by the conductor placed in magnetic field is proportional to the magnetic field strength. It also proportional to the amount of current. It is also proportional to the length of the conductor. So out of these 3, you can write any 2 you can write. Okay, fine. Now B. With the help of which rule you can determine the direction of force acting on a current carrying conductor placed in a magnetic field? Children, it is a Fleming left hand rule. It is what? Fleming left hand rule. Left hand rule. Here you no need to define because they did not ask. Just they asked with the help of which rule. So you have to write the name of the rule. That is Fleming left hand rule. So what is the Fleming's left hand rule, children? So middle finger and forefinger, thumb finger of the left hand should be arranged so that they are 3 are mutually perpendicular to each other. Then if the current is in the means the center finger should be in the direction of current flow and forefinger is in the direction of magnetic field. Then thumb will give you the direction of the force acting on the conductor or motion of the conductor. Okay, fine. Now third bit. Children, here what is the nuclear energy? Here there will be confusion actually. This nuclear energy term is related to the work bar energy, that is in the first sem, and even it is related to the what we can say radioactivity of unit B. These 2 are not in the question actually. So let us wait for the council whether mark will be added or not. That we have to wait for the council only. So first, what is the nuclear energy? Children, during the nuclear changes, might be a nuclear fission or a nuclear fusion, what will happen? There will be some mass defect, some mass will disappear. That whatever the mass which is disappeared in a nuclear reactions will convert into energy. That only we can call it a nuclear energy. That we can calculate with the help of E is equal to mc square. By using the Einstein equation, we can calculate the nuclear energy. Okay, fine. Now third bit, that is A. Now B. After emission of a nuclear radiation, the atomic number of the daughter nuclei increases by 1. Identify the nuclear radiation. Children, it happens only in the case of beta decay. It happens only in the case of beta decay. In a beta decay only, atomic number is increased by 1. Now C. So write a nuclear reaction indicating the nuclear change mentioned in a B. So they are asking us to write. So you can take a general equation or you can take example also. You can take a carbon conversion into nitrogen you can write, or a general equation also you can write. Like this, for example, X, atomic number is Z, mass number is A. So here what will happen? Beta is emitted So that here it is going to be a daughter nuclei with Z plus 1, here is A. Okay children, so here we should write here example also. Here for example, carbon C614 will convert into nitrogen 714 plus here is beta particle. And children here, if you are able to do the bit C only, you are able to do the bit D also. It's related. So what is the bit D here? What is the special name given to the parent and daughter nuclei when this radiation is emitted? Children, now try to understand, try to notice here, parent nuclei, daughter nuclei. Atomic number is same. Sorry, atomic number is different, but mass number is same. Children, the atoms belongs to the different elements having different atomic number but same mass number are called what? Isobars. Or called what, dear children? Isobars. That's it. Okay. So this is question number 4. Now in a question number 5, children, you can look at that question here. It is given that an appliance rated 540 watt 220 volt and it is connected to the 220 volt power supply. So first of all, let us write what actually given. Children, here power is given 440 watt and here V value is given 220 volt. That is fine. Now here they are asking us to calculate maximum current that the appliance can draw. So children, we have this relation P is equal to VI. So from this we can calculate I is equal to P by V. That is, it is 440 by 220 V. 0, 0 cancel. 11 2s are, 11 4s are, 2 1s are, 2 2s are. So here I is equal to 2 ampere is a right answer. Now in this only, the second question it is asked, calculate the resistance of the appliance. Now R value they are asking. So children, we know that P is equal to V square by R. From this we can write R is equal to V square by P. Now let us substitute V value, that is 220. So 220 square we can write as a 220 into 220 by it is 440, it can be written. Now here 221s, 220, 2s we can do it. So 2 1s are 2 110. So here resistance of the appliance is 110 ohm, children. So you should not forget to write the units. Fine. Now we'll see the second part of the fifth question. So children, you can look at the diagram on the screen also. It is given that first question, what is the frequency of tuning fork E? Children, in a question only a clue is given. What is that clue here? With means tuning fork B only. When tuning fork B is placed only, louder sound is produced. Louder sound is produced means what here? That is, tuning fork E is in resonance with tuning fork B. It happens when both frequencies matches. So the answer is question number 2. A. Answer is, what is the frequency of tuning fork E? So frequency of tuning fork E must be equal to the frequency of the tuning fork B. But in exam, what we should write? You should write it as a 320 hertz. You should write 320 hertz. We should write. Okay, fine. Now question B. Why does B produces louder sound? Children, it is because of what? Resonance. Because of what? Resonance. But you need to write a little bit extra information regarding this. What is that? As the frequency of B matches with the frequency of E, both will be in resonance, due to which what will happen? Both will be vibrating with increasing amplitudes. Children, when amplitude increases, then only louder sound is produced. So this is information which we have to write. Okay, fine. Now moving to the third part of the question number 5. Third part. Children, here from the graph heating curve given below, state the melting point and the boiling point. Children, it's a very easy, dead easy question it is. So in a diagram it is very clear, it is shown. At what temperature? You look at that at 40 seconds. So at 40 degrees Celsius, children, if you can look at that, the curve is flat, which means what? During that period, here temperature is not rising. Rather, there will be a change in state. So as it is the initial state, it will be from solid to liquid. So here melting point is given 40 degrees Celsius, and similarly they are asking us to write the even boiling point also. Children, so next if you can notice the diagram, next if you can see at a 160 degrees Celsius, children, there is no rise in temperature. So during that time what is happening? There will be a conversion of liquid state to the vapor state. That only we can call as a boiling point. That temperature related only we can call as a boiling point. So here boiling point is given, clearly it is a 160 degrees Celsius. 160 degrees Celsius. Now children, so it is a complete A. Now B part. So here one equation is given, children. They are asking us to fill the equation. Look at that question here. So let me write here 24. Children, He24 is what here is? It is a alpha particle. It is a alpha particle. Now children, so we have to here, for writing atomic number of uranium 1 mark. For writing the mass number of thorium here 1 mark actually. Okay, now fine. Now we know that here you can see that what a conservation of mass here, children. Means during a nuclear changes, children, mass number and what we can say charge must be conserved. So here right side if left side if you consider 235. So here 4 is left. Children, even in alpha decay we all know that whenever alpha particle is emitted, mass number is reduced by 4. Here is a 235 means it must be 231. That is fine. But whereas atomic number is decreased by 2. Children, after decrement it is a 90. Means before how much it should be? It should be 92. Now you can cross check also. Here 92 left side. Right side 90 plus 2. Yes, 92. Whereas it 235. Right side 231 plus 4. It is a 235. So children, this is a question number 5. Now we will move to the question number 6. Children, you can look at the diagram actually. So here graph is shown. Now under this question number 6, again 3 bits are there. So question number 6, first bit let us see here. So here study the above figure and answer the following questions. Okay, you can look at the graph on the screen. Question number A, what type of vibration does the above figure represent? Children, in this diagram if you can see, the amplitude is decreasing with the time. It happens only in presence of medium. Such a vibration is called what? Children, it's a damped vibrations. It is called damped vibration. So writing damped is enough because what type of vibration is mentioned. You may write a damped or a damped vibration. Everything is accepted. And here B. The first bit it is A. And again it is a B. Question B. State one reason for which the amplitude of the vibration decreases with time. Children, in presence of external medium, what happens? That oscillating body, whatever it may be, so to continue its oscillation, it has to overcome the external, what we can say medium, external resistive force. To overcome that external resistive force, dear children, it has to spend energy. So for every oscillation, some amount of energy is spent. So slowly what will happen? Its energy keeps on decreasing. Means due to the energy lost, we can say that. Okay, fine. And question C here. Question C. Write an example of natural vibrations. So first of all, think here. Natural vibration occurs in the absence of external force, in the absence of medium, happens in vacuum. Means oscillations of pendulum in a vacuum is a best example for a natural vibration. Means vibrations of any object in the absence of external resistive force comes under natural vibrations. Clear? Fine. Now question 2 in this second bit in a question 6. Children, it is given that a certain beam of alpha particles, beta particles and gamma radiations travel through a region of electric field produces between two oppositely charged particles. Okay, fine. Plates. Here question A. Which of the above three has the maximum speed? Children, gamma radiations belongs to the electromagnetic waves. And even we know that, children, here. So the speed of the alpha is 10 power 7 meter per second. Beta is 10 power 8 meter per second, whereas gamma is 3 into 10 power 8 meter per second. So The answer is gamma. Of course, in exam you no need to write these three. Directly you can write just gamma is enough. Even you no need to mention the value also. So gamma is the right answer. Now, question B here. Which one deviates the most from its original path? First of all, dear children, gamma does not deviate because it is electrically neutral. And come to the alpha and beta. Children, here beta will deviate more. It's very important. Beta will deviate more. Why, dear children? Because it's due to its less mass, least mass. Okay, fine. Now question C here. Which one does not deviate at all when passing through a region of electric or magnetic field? Of course, it is nothing but gamma only. Why? Because it's electrically neutral. That's it. Okay, dear children. So this is the second bit. Now third bit we'll see here. Question number 6, third bit. Children, here is a numerical. It is given that if a wire of resistance 2 ohm gets stretched to thrice to its original length, calculate the new resistance of the wire and what happens to the specific resistance of the wire. Children, it is a stretching case. Children, it's very important. Whenever we stretch, what happens? Children, its length increases, area of cross section decreases, but children, don't forget that volume remains constant. So for this actual teacher, two methods are there. So let us discuss the two methods here. So children, let it be, first it is the initial wire of resistance R, its length is L and area of cross section is A, let us say. Area of cross section is A. So it is given initial resistance is 2 ohm. Children, for this here R is equal to, we can write that rho into L by A. Let it be, it is equation 1. That is fine. Now children, if same wire is stretched to what we can thrice to its original length, means what is happening here? New length is 3 times of its original length. Then what will happen, children, here? During stretching, volume remains constant. So as the length is increasing, area of cross section decreases by 3 times. So here new area of cross section will become A by 3. Now they are asking us to calculate its resistance in this case. Children, can we write like this? R dash is equal to rho into L dash by A dash. Of course, we can write. And in the place of L dash, rho into, we can write 3L by, it is A dash, in the place of A dash, we can write the A by 3. Yes. So it will be R dash is equal to, children, it can be, this 3 will go to the numerator, 3 3 that is a 9 into rho L by A. Now children, it is the equation 2. Now you can notice, children, here rho L by A is equal to R. So can we substitute in this? Yes, we can substitute. So that here we will get, children, here R dash is equal to 9 into R. So R value is given, that is 2. So it is 9 into 2. So it is a 18 ohm is the answer, children. 18 ohm is the answer. Fine. So for this we have even shortcut method also, children. It is the, let us see even shortcut also. What is that? In a stretching case, children, resistance is proportional to the L square. In stretching case only in stretching case, this can be written as R1 by R2 is equal to L1 square by it is L2 square. So children, let us say R1 is the initial resistance, that is 2. R2 is a resistance after stretching, that to be calculated, and L1 is a initial only, and L2 will be what? 3 times L, that is 3L whole square. So this will become 2 by R2 is equal to L square by 9 into L square. L square cancel. Now you can do the cross multiplication. Here R2 is equal to 18 ohm. That's it. So anyhow you will get the both. But children, first preference should be given to this only. If time is less, if you are unable to recall this method, you can go for this. But first priority must be given to this only. Okay, now fine. And in this, it is a third bit A. Now third bit B. Even children, what happens to the specific resistance of the wire? Children, specific resistance, it does not depends on dimensions. It depends only on the length and, it depends only on the temperature and the nature of the material. As long as the nature of the material is same, dear children, specific resistance is same. So in this process, what are we doing? Just we are stretching, we are not changing the material. So which means the answer is specific resistance remains constant. That is, rho is a specific resistance remains constant. That's it. For writing specific resistance remains constant, you will get a 1 more mark. Okay, children. And children, so this is our discussion of entire semester 2 physics paper. A big relief for teachers, parents, and especially, of course, no doubt about it, it is you all the students. And yes, we can understand the tension which you have taken, the pressure which you people went through, because after the semester 1, you know, it's there was a big question and a big confusion in students whether they are going to do the well or not, how the paper is going to be. And it's you know, of course, if we perform well in our 10th final examination, the same thing is carried to the intermediate also. But really, children, it's a very big relief for students, teachers, and parents, for all of us. Okay, na? And once again, a big congratulations for your performance and the hard work, especially, I can say that. So definitely, you all will carry this hard work and what we can say, the love towards the physics, okay, for your higher class also, and you are going to the best in our next your exam, whatever you are going to get in your next level of your future. For all exams, you are very well in advance. All the very best, and a big congratulations to you all. Thank you so much. All the very best.